Hi, guys, girls, and non binary pals. So, hope you're all well. This is your awkward Indian linguist back again. I've been meaning to do a video for a long time now, but I haven't found any free time. So, today I'm back again. I have some free time this week. So, today I want to talk about a topic which is on everyone's minds these days. I mean, on every linguist's minds these days. So, how to transition into tech, right? And I've shared some of my thoughts on LinkedIn and in writing, and also I've made like videos on this topic. But then today I want to kind of focus on a few points. I've seen a lot of content on this, and I've seen thoughts and opinions of others, so I thought I should like add to the conversation with my thoughts and opinions, right? And also based on my own experiences. So yeah, so I should add a slight, additional information. So I didn't start as an undergrad in linguistics. So I started as an undergrad in engineering. In my undergrad was in information and communication technology, but I can tell you that I was more interested in linguistics than in engineering during my undergrad. So I was mostly reading books on linguistics by myself. I didn't have there weren't any courses. There were a few like courses on like general linguistics, but then I didn't have any coursework. The main thing that I did was my undergrad thesis project was on machine translation, where I did like a rule based approach to mapping prepositions from English to like postpositions in Hindi. So that's when I learned all of this, syntax, etc. So I was reading Andrew Carney's textbook, and then I took a course at EFLU Hyderabad. So yeah, so those things kind of made me made me convinced me that I wanted to be a linguist. I mean, I kind of already had the inclination for a long time. So, but then, yeah, so the main point that I'm trying to say is I don't see myself as somebody with, a tech degree who transitioned into linguistics. I see myself as a linguist who transitioned into tech. Because, yeah, back then my goal was to just be like an academic linguist, and I wanted to kind of, work on revitalization of languages, do like field linguistics and things of that nature. Not really, I didn't think of myself. I mean, I did know about NLP because my undergrad thesis was on NLP, but then, yeah, it was like fine. NLP wasn't trending back then, so NLP was started trending only recently. So in 2005, 2006, there wasn't much, talk of NLP. And it was something that okay fine, I did it, but mostly because it was more appealing to the linguist in me, the project that I took up. And if you look at my GitHub even today, you'll see all my projects have more of a linguistic element than a machine learning element. So I always talk about I'm always working on like the linguistic aspects of a script, or like linguistic aspects of like, let's say, um, speech recognition, or various other projects that I have. So yeah, I think what I have to say would be relevant to linguists who are transitioning into tech, right? So yeah, I made a brief kind of mental note of few points which I thought would be useful. So yeah, I'll go over them one after the other. So the first thing which I see quite a lot is, you know there is this assumption that there is somehow like a one size fits all approach, that there is like one path to transition from linguistics to tech, which needs to be followed. But this is completely untrue, because every linguist is unique. So each of us have a unique background in linguistics. So even the courses that we took, the kind of ideas that we were exposed to, if you were, if you went to an American university, let's say if you went to Stanford or MIT or any school, they will teach the ideas the professors at that university are working on, right? So if you went to university in the UK, you would get exposure to those ideas. If you, like, when I started working on linguistics, when I was at the kind of people that I interacted with were mostly historical linguists. So the late Professor Krishnamurti, the late Professor Lakshmi Bai. So Professor Lakshmi Bai worked on many things, but then I was mostly discussing historical linguistics with her. So those are my formative experiences. So those will be there with me, and I should not, sort of like undervalue those experiences. So those experiences will contribute towards me being a unique kind of computational linguist. So it's not that I have to shed all that baggage and I have to rebrand myself, and while rebranding myself, I have to kind of follow a beaten path of, like, machine learning, train a few machine learning models, train an image recognition model, train a speech recognition model. No. So you have all that background, and then you will acquire new background in machine learning, and then you will combine the two in your own unique way, and that's when you will be the most, saleable. So I mean, that's when you will have the maximum chance of success. You will not have, you will not have the your best chance of succeeding will not be when you copy someone else's pattern. Okay, this sounds very, like, sounds very commonsensical, but this is actually true. I can tell you from my own experiences, the opportunities that I got, I was able to perform in those roles, and I was able to create a niche for myself because I knew things which other machine learning engineers didn't know. So if you're like doing some accent adaptation, right? So you need to know things about the accent that you're working on. You need to know about, like, accents of English and all the linguistic details, and then try to see if you can incorporate that knowledge into speech recognition. So, a standard run of the mill, machine learning engineer who knows only about, like, changing the architecture of, let's say, a transformer model, or training with some new data sets, etc., they wouldn't be able to, they wouldn't be able to think the way I did with my background in linguistics. Sure, you need to learn all about machine learning as well. So you need to constantly learn and upgrade and, like, develop new skills, but don't undervalue the skills that you already have as a linguist. Number one, right? This is the first point that I want to, people to think about. I don't want you to agree with me. I want you to think about these things. I don't want you to accept what I say. I want you to think about these things, and then, verify these verify these opinions with your experiences in the real world. I mean, put them to test, and then see if they feel true to your experience, and only then you can sort of, incorporate these into your worldview. So the second thing is, this is another huge problem. You know, computational linguistics is not the same as Python scripting or Java scripting, or, let's say, it's not the same as packages. Okay, so it's not Spacey, or it's not NLTK, or it's not Stanford NLP, or it's not PyTorch, or it's not. So all of these are tools. Okay, so don't confuse the tool with the object of study. So the object of study is something else. Object of study is computational linguistics, which is creating models of natural language which can be used to teach the machine how to process natural language. So for that, you already have a lot of background because you did linguistics, which is about theories of language processing, and you know what all is required to understand a language. There are various levels, so you have to understand the phonetics, you have to be able to understand, like, the intonation, you have to be able to understand syntax, semantics, pragmatics, all those layers, all those levels you have to understand. So if you have an understanding of how these things can be modeled so that they can be taught to the machine, then you are a computational linguist. You don't have to know Python scripting. So Python scripting will sort of, it's a very useful skill to have, but that is not computational linguistics. Similarly, Spacey and all these toolkits, they are very good to learn about things, but they are not the thing that you want to learn. The thing you want to learn is how to solve problems related to, you know, machine processing of language. So, for example, if you get hired as a computational linguist in any job, they will not ask you to write a script with Spacey, or they will not ask you to do something with, like, let's say, PyTorch. They will be building a product, and they will face problems related to, they will face problems related, for example, let's think of, okay, I give this example all the time. So again, let's think of, let's say you are building a speech recognition model for a new dialect of English, Scottish English, or let's say the Shetland Islands English, where I just went for a holiday. So you're building, uh, you know, um, a speech recognition model for the Shetland Islands English. So how do you go about that? So if you do you understand the problem, and how can you solve that problem given whichever toolkit you want to use? Okay. So if you use, like, let's say, a deep learning approach, and if you kind of take a generic model of English speech recognition from, let's say, Hugging Face, or I mean, I won't even mention the tools that you use, but let's say you take a model like that, then how can you fine tune it, and what sort of data do you need to fine tune it? So this is the sort of problem solving that is required. And let's say if you have a traditional approach, if you have a more, like, modular system like Caldi, for instance, right? So there you have the option of improving your lexical model by including transcriptions of the words, of words from that dialect, the pronunciation of that dialect, and then incorporating it into your speech recognition model. So that is the thing, that is the unique skill that you will bring to the table. Anyone can, write a piece of code to sort of, take an off the shelf toolkit and then do some stuff, but you have to develop the problem solving ability. So yeah, let's take another example. For example, you are a company which is interested in extracting information about relationship between, uh, like, let's say, genes from a biomedical corpus. So you have two different kinds of genes, and or let's say you just have one gene, and you want to kind of extract all the different kinds of information that you can find about the gene from a corpus of biomedical texts. So as a computational linguist, how will you think about this problem? How will you go about solving this problem? So you need to know that, okay, there is a way to extract information from sentences, right? So first of all, you need to know about POS tagging, and POS tagging for the biology domain, and then how can you extract, like, the terms which correspond to genes, right? I mean, you can have a very simple approach, which is to maintain a list of all the genes that you are interested in, and then look at that. Or you could have a more, if your problem is more open-ended, if there is like an open-ended list of genes, then you need to kind of have a more you need to use a POS tagger, or even like a parser or a chunker. So yeah, you need to understand what's the difference between a POS tagger, chunker, parser, named entity recognition, and all of these concepts you need to understand, and then use those tools to solve the problem. Okay. So it's just like any other, it's like any other skill. So you are, let's say, I love DIY stuff, I love building things. So I need to build, let's say, a table. Okay. I need many tools to do the job. I need a hammer, I need screwdrivers, I need probably even need the pliers. But those are the tools. I need to know how to fix the table, and that's the algorithm. So the manual which has all the steps. So figuring out that manual is your job. That's your job as a computational linguist. So that is putting together the solution. So it's not the tools. Okay? So please don't confuse the tools with the object of the study. You want to be a computational linguist, and you want to know how to use different tools, but these are two different things. Okay, I think, yeah, I won't belabor this point anymore. I hope you understood what I am trying to, get across. The third thing is again another tricky thing, which is actually, yeah, is kind of, I can understand. So when you're transitioning, you kind of rely on courses, right? So there is Udacity, there is Coursera, and all of these courses. So they provide very useful courses. The problem with these courses, again, is the same as the first point that I said. Like, there is no assembly line approach here to produce computational linguists. So those courses will give you skills, but you need to think beyond the courses. Because if you think about it, right, look at the state of art. Look at the models, like let's say text to speech models that Google is producing, right? Or Amazon is producing. Even they have severe limitations. They don't work with data which is more than, so the training data is mostly like sentence level training data, and sentence level training data never really captures the intonation and prosody effects, because as linguists we know that prosody and intonation are kind of related to information structure, right? So in a conversation, like, my intonation, so if I have a sentence, even if I have a simple word like really, right, really, there is multiple ways of, like, there is, I can say really, really, really. So there are many different ways of, like, intonation. So yeah, I probably did a bad impersonation there, but yeah, the main point I'm trying to put across is even the state of art models are not super smart. As a linguist, you know much more than what the knowledge that went into building these state of art models. But you need to trust your knowledge, you need to trust your own intuition, and then approach these courses as stepping stones. Okay, you will learn about this, and then you will also understand the limitations of the models that you're being, shown in these courses. So don't think that, okay, if you have trained an MNIST, let's say you have trained a handwriting recognizer, a CNN based handwriting recognition system using the MNIST data set, that you have transitioned into like a computational linguist. That's just a small project which kind of gives you familiarity with these tools. But then the second point that I mentioned, the problem solving ability, is what you need to develop. Given a problem, a real world problem, how can you apply computational linguistics? How can you apply linguistics to solve the problem? So that is what should be your goal. And all of these tools are really useful, but they are not the real thing. The real thing, if you want me to put it that way, is the ability to think up solutions for, real world problems, where the solutions are, based on your understanding of natural language. So yeah, so basically, if there is going to be ambiguity of some sort in the language, you need to be able to foresee that, and then you need to kind of tailor your solution in such a way that the tools, because the tool won't know all these things about the ambiguity and all of those things. It's just going to parse the sentence and give you the parse tree, that's it. But if there is, ambiguity, and then you need to kind of be careful about like how to extract the relations. So all of those things are your unique skills that you're bringing to the job. So yeah, so again, to kind of recap, first, there is no one size fits all. Each of us is a unique combination of like linguistics and computational skills. So there will be different kinds of computational linguists. There won't be like any one specific path which will lead you to becoming a computational linguist. Second is the problem solving approach, the focus on the problem solving approach rather than the tools. So the tools are not the object of the study here. And number three is this thing, that courses, when you take courses, online courses, again, the course is not the thing. So whatever you're taught in the course is not, so most of the state of art models have limitations. So don't think that, like, don't look up to those models and think that, okay, if I learn this model, that's like, the ultimate. No, it's not ultimate. You can actually better it if you actually, trust your own abilities and, point out the limitations of that model. So as more and more linguists get into this field, as there is more and more awareness, you know, language technologies will become more receptive to ideas from linguistics, and it will become a more richer area. So this will happen slowly, and we will all do that. So there is, no rush. It will happen over the next few years. So, but the main process is this. So don't undervalue yourself. Don't try to become an imitation of a machine learning engineer. No need. Learn machine learning. That's very good. It's very useful, and it can actually even help you become a better linguist, because you can think, okay, like, how do I, create a theory which will perform well on unseen examples. So there are all of these things that you can learn from machine learning. Okay. And there is one other thing that I had a mental note of it, and kind of, it's there in my head, but it's trying to come out. But I think, yeah. So the other thing is, yeah, like, for example, yeah, this is again related to, I've already mentioned this thing before, that real world problems are never, it'll never be that, so in coursework you will have very explicit sort of exercises, problem sets. Okay, train an image recognition model, which will, you have a training data set, and then it should get an accuracy of, let's say, 95% or 96% on your test set. So, but real world problems are seldom like this. You have a problem, and even to see the problem as, like, a machine learning problem is, part of the solution. So yeah, so that's very important. So don't expect real world problems to be like, to be formulated, to be couched in familiar terms. They'll be they will be, you know yeah, I mean, like, if you're working in a startup, right? So most likely you would be the only computational linguist. So they will not understand computational linguistics. The other full stack developers will not understand computational linguistics. So they will face a real world problem, which is that, okay, let's say Google Speech API is not doing well on the data that they are getting from their clients, and they want to improve that, but they don't know much beyond that. And they, you know, delegate that task to you. They give that task to you. And from there, it's your job to sort of, understand the problem, and then break it down, and then see, like, the linguistic components and improve it. So I think that's very important to kind of develop that level of, abstract thinking. So it's not just the skills and the familiarity with the toolkits. uh, I think, yeah, that's about it for now, but I think I'll share more thoughts. I hope you find this useful. And I think, yeah, things look very promising. I see a lot of interest from many young people in this field, and it's all going to kind of change. I have the strong feeling that within the next 5 to 10 years, we'll see a lot of change. It won't be the same, but and yeah, the language technologies folks are also changing. They are kind of waking up to the importance of linguistics. So they understand that, they can't really proceed much further without engaging with linguists. So there is definitely change in the air. But yeah, I think as linguists, yeah, don't have any anxiety. It will work out if you do it everything sincerely. If you do everything sincerely, it's inevitable that it'll work out. So don't really have any sort of, like, panic. And that, okay, I have, yeah. So the most important thing now, it is come back to me. So the most important thing that I notice is that people set themselves very harsh deadlines. okay, in 3 months I'm on job search, and in 3 months I need to develop Python skills which will get me a job in Google. That's like, you are just, setting yourself up for failure. You are setting yourself up for frustration, because to learn, to become a good coder, to become a good programmer, it will take you significant amount of time, and you will learn it in small iterations. You will learn a little bit, you will feel proficient, and then you will try to take up something which is uh, beyond your level of understanding, and then you will be disappointed. So it will be sort of like a, you learn it in iterations, and that's something that all of us have to be prepared for, and it's completely normal. So don't set yourself these very harsh sort of deadlines. And this is, again, it's there in the culture. So they kind of there is this sort of thing that, okay, by the time you graduate you should have a job, you should land a job, and then so you have to do your coursework, and on the side you have to take many courses in coding, and kind of, so I mean, you don't have to be paranoid like that. So just finish your linguistics coursework, and you finish your degree in peace, focus on that, do well. Then once you start your transition, then give yourself enough time, set yourself small goals, and proceed. And the other thing is, yeah, so the other thing is, I hear people say, oh, I'm not good at coding. That is, again, another thing which you need to challenge. Because as linguists, you are very good at communicating ideas. If you are very good at communicating ideas to others, if you are very good at putting your thoughts into words and communicating your ideas to others, then there is no way that you will be bad at coding, because coding is exactly the same. You are communicating with the machine and telling it more explicitly. So unlike with humans, with a machine there is no, like, reading between the lines. You have to be very explicit, and then you have to explain things in a very logical way, so you can be a good coder. So again, with coding, it's not about like the tips and tricks of Python, or like, it's not about becoming like, a superb going on like these lead code websites like lead code and solving the tough problems and cracking some coding tests. No, it's about, you want a machine to do something for you, right? And then you think of a logical way of explaining that to the machine, write it down, and then figure out the syntax for that language, whether it's Python or Java, to express what you think, the logical pseudocode that you have, the logical algorithm, and then you express it in that code, and then you make the machine do it. And if the machine is failing to do it, then you correct your code, and then again go again. So that's it. So don't mystify coding, and don't kind of make it harder than it is supposed to be. And I see that like very often, that linguists are they are freaking out. Okay, but I'm not good at coding, I don't like coding, so how can I transition into computational linguistics? So first of all, as I mentioned before, coding is not computational linguistics. If you can figure out the solution, and even if you can't code it, then you are a computational linguist. And coding is, again, something different. Coding is something which, again, it requires a bit of time, a fair bit of time. So it will take you 6 months to a year to kind of pick up the coding skills, and you have to give yourself that time. And yeah, if you are a good communicator, if you can put your thoughts across to other human beings, then there is no way that you can't be a good coder. Okay, so I think it's already quite long. I hope you like this video, and yeah, subscribe to my channel. I can't promise that I'll do these videos regularly, because yeah, as I mentioned, I'm kind of trying to reduce my social media consumption, because it's, yeah, quite tiring after a regular job. But yeah, I will try my best. I'm actually more comfortable with writing posts. So yeah, we'll see how it goes. I hope you all have fun, and all the best to you in all your projects. And yeah, keep up with the good work, and I'm sure all of you will reach the goals that you've set for yourself. Bye.